In the history of humanity, there are technologies capable of changing the world so dramatically that after their appearance, civilization literally begins to live by new rules. Once, such a technology was the wheel, then the steam engine. Later came electricity, aviation, the internet, and rockets that allowed humans to leave the boundaries of Earth for the first time. But there is one idea that for more than a century has been considered perhaps the most revolutionary concept in the entire history of space exploration. Many leading engineers call it a true dream of humanity. Others describe it as the most insane engineering project ever seriously discussed. And some scientists believe that if such a structure is ever actually created, that day will mark the beginning of a new era in space. Today, we are talking about the space elevator. At first glance, the very idea sounds so futuristic that most people assume it belongs purely to science fiction. Imagine a gigantic structure extending far beyond Earth's atmosphere, but it is not actually a tower. It is an incredibly thin, yet ultra-strong cable, almost 100,000 kilometers long, connecting the surface of our planet with space. Instead of rockets, special electric cabins would move up and down along this giant cable, like ordinary elevators inside a skyscraper, except that instead of reaching the 50th floor, they would be capable of carrying a person directly into Earth orbit, without a deafening launch, without hundreds of tons of burning fuel, without extreme overloads, and without expensive rocket launches. Until recently, such an idea seemed impossible, but today it is discussed not only by science fiction writers, but also by some of the world's largest engineering companies, space agencies, and scientists working on the materials of the future. That is why in recent years, interest in the space elevator has begun to grow rapidly again. New studies focused on ultra-strong materials, orbital infrastructure, and the possibilities of building such structures are appearing more frequently in scientific publications. Many specialists believe that if humanity truly plans to build cities on the moon, extract valuable resources from asteroids, and eventually transform Mars into a second planet for human life, then achieving this without a fundamentally new method of delivering cargo into space will be extremely difficult. And the space elevator looks like one of the boldest ideas capable of changing literally everything. But what exactly is such an elevator? How would it work? Why can't it be built today? Who is actually researching such technologies? Why have the world's largest space agencies not completely abandoned this idea? What has Elon Musk said about it? Could SpaceX build such a structure before anyone else? And could humanity really one day stop relying on the launch of most rockets? This is exactly what we will discuss in detail today. The most surprising thing is that the idea of a space elevator did not appear in the 21st century. The concept was first proposed by Russian scientist Konstantin Tsiolkovsky at the end of the 19th century. Inspired by the construction of the Eiffel Tower, he imagined a gigantic structure extending far into space. Later, engineers realized that building a tower of such height was impossible, but the idea of connecting Earth with orbit remained alive. Over time, scientists proposed a completely different approach, using not a tower, but an ultra-strong cable held in place by the centrifugal force of Earth's rotation. This concept is now considered the classic space elevator design. If we imagine Earth from space, we can picture a massive cable attached exactly at the equator. The upper part of the cable passes beyond geostationary orbit and continues for tens of thousands of kilometers, where a massive counterweight is located. Due to the rotation of our planet, this counterweight constantly keeps the cable stretched, maintaining it in a stable position. Special electric climbers then begin moving along it, receiving energy either through the cable itself or through lasers transmitting power over a distance. Gradually, such cabins would lift equipment, satellites, construction materials, and even people directly into space. The most incredible thing is that such a system would require almost no use of enormous amounts of rocket fuel. Today, one of the main reasons space launches are so expensive is precisely the need to accelerate a multi-ton rocket to orbital velocity. Every ton of payload requires massive fuel reserves. Even the most advanced reusable rockets remain extremely complex engineering systems. A space elevator could potentially change this entire economic model. Imagine that instead of launching hundreds of rockets every day, ordinary cargo trains arrive at the base of the elevator. Containers are loaded into cabins, which then slowly begin moving upward. After several days, they are already in orbit. The cost of delivering each kilogram of cargo could decrease by dozens of times. Some studies suggest that in the distant future, it could fall from thousands of dollars per kilogram to just a few dozen dollars. For the space industry, this would represent a true revolution. That is why many engineers compare the space elevator to the emergence of railways in the 19th century. While people transported goods only by horses, the economy grew slowly. But once railways appeared, industry began developing at a completely different pace. A similar transformation may await space. Instead of individual launches, humanity could organize an almost continuous flow of cargo between Earth and orbit. However, this is where the most difficult part of the entire story begins. The main problem of the space elevator is not money, and it is not even the enormous size of the structure. The main problem is the material of the cable itself. Today, there is no material that is both light enough and strong enough to withstand the required tensile forces. Ordinary steel would break under its own weight after only a few dozen kilometers. Titanium is also unsuitable. Kevlar, used in body armor, is too weak. Even the most advanced composite materials available today still fall far short of the required properties. For decades, the main hope of scientists has been carbon nanotubes. Their theoretical strength really could allow the creation of the necessary cable. However, the problem is that humanity can currently produce only very small structures from these materials. A space elevator would require an almost perfect cable tens of thousands of kilometers long without a single critical defect. At the moment, such technologies remain far beyond modern manufacturing capabilities. In addition to strength, there are dozens of other challenges. The cable would constantly be exposed to micrometeorites, space debris, temperature fluctuations, solar radiation, and electrical discharges in the atmosphere. Any serious damage could lead to catastrophic consequences. Therefore, engineers would need to develop a complex system of automatic monitoring, continuous repair, and structural redundancy. Another extremely difficult issue remains the choice of construction location. The elevator's base would need to be located almost exactly on the equator. Ideally, it would also be positioned over the ocean to reduce risks to densely populated areas. But this creates a question of international law. Who would own such an object? Which country would be responsible for safety? Who would be allowed to use the elevator? How would maintenance costs be distributed? What would happen in the event of conflict between nations? All of these questions still remain without final answers. The cost of such a project is also the subject of major debate. Some studies estimate construction costs at tens of billions of dollars. Others believe the real cost could exceed several hundred billion. Some analysts even suggest that the full development cycle, including advanced materials, infrastructure, the orbital counterweight, and the ground station, could approach $1 trillion. At the same time, the final cost will depend not only on engineering solutions, but also on the price of new materials, energy systems, and automated manufacturing. Despite this, interest in the idea has not disappeared. One of the most famous companies that has openly discussed the possibility of building a space elevator remains the Japanese Obayashi Corporation. Company representatives have published concepts suggesting that if the necessary materials become available, such a project could one day become a reality. Japanese research groups have also conducted small experiments with miniature space elevator models between satellites, testing individual engineering principles. Research is also being carried out at various universities and within separate NASA scientific programs. However, specialists emphasize an important detail. This is not yet about the beginning of construction, but about fundamental research into materials, cable dynamics, and possible architectures of future systems. But what about Elon Musk? Why does SpaceX say almost nothing about the space elevator? The answer is quite simple. Musk has repeatedly indicated that he considers reusable rockets to be a much more realistic way of expanding into space in the coming decades. In his view, the main problem with the space elevator is not the boldness of the engineering concept itself, but the lack of the necessary materials. until a completely new class of ultra-strong fibers appears, building such a structure remains extremely unlikely. That is why SpaceX is investing in a completely different direction. The company is creating the fully reusable Starship transportation system, developing orbital refueling, launch automation, and mass production of spacecraft. The logic here is very similar to the development of aviation. Instead of waiting for futuristic technologies, engineers are improving what can already be implemented today. However, many people ask the question, what if the materials problem is eventually solved? Could SpaceX then become the first company to build a space elevator? Theoretically, such a scenario cannot be completely ruled out. If we imagine that a material with the required strength appears in the future, then the company that possesses the world's largest system for delivering cargo into orbit could gain a major advantage. After all, building a space elevator itself would require transporting enormous amounts of equipment into space. Here, SpaceX's experience, the advanced Starship system, and large-scale manufacturing capabilities could indeed become extremely valuable. But for now, this remains only an engineering possibility, not an actual company plan. Some futurists even believe that the first space elevators may appear not on Earth at all. Building such structures on the Moon or Mars looks much more realistic. There, gravity is significantly weaker, meaning the requirements for cable strength are much lower. That is why many specialists believe that if humanity eventually establishes permanent bases on the Moon, the first operational elevators could connect the lunar surface with orbital stations long before an Earth-based version appears. This is why the space elevator remains one of the most fascinating technologies of the future. Today, it seems incredible, almost like science fiction, but many great engineering achievements of the past were once considered impossible as well. Heavier than air flight, supersonic aircraft, human missions to the Moon, reusable rockets, all of these were once viewed as unrealistic dreams. Perhaps, in several decades, humanity will truly take the next step and transform space from a rare destination for individual missions into a normal transportation route. And if that day ever arrives, it is entirely possible that the space elevator will become the very structure that forever changes the history of our civilization. But even if we imagine that humanity manages to solve the problem of creating an ultra-strong cable, an enormous number of engineering challenges would still remain ahead, each of which could become a separate project of global scale. For example, few people realize that a space elevator would never be completely motionless. The Earth is constantly rotating, the atmosphere is continuously changing, the solar wind affects the upper sections of the structure, and the Moon and the Sun create additional gravitational disturbances. This means that a giant cable almost 100,000 kilometers long would constantly experience small oscillations. Even a deviation of only a few meters at the upper section could lead to enormous shifts across thousands of kilometers of length. Therefore, engineers would have to create an extremely complex active stabilization system operating around the clock. Another equally interesting challenge is the problem of space debris. Today, tens of thousands of tracked objects and millions of smaller fragments are orbiting the Earth. Even a small piece of metal only a few millimeters in size can travel at speeds of more than 7 kilometers per second. Such a collision releases enormous energy. If such an object hits the cable of a space elevator, the consequences could be extremely serious. That is why many researchers suggest making the cable not as a single solid structure, but as a system consisting of many independent fibers. In this case, even damage to several elements would not lead to the destruction of the entire structure. Moreover, specialized service robots could constantly operate nearby, automatically detecting and repairing damage. The next challenge is related to energy. Many people ask, if the elevator cabin rises to a height of tens of thousands of kilometers, where will it get its power from? After all, installing a traditional electrical cable along the entire structure would be practically impossible. That is why several options are being considered. One of the most interesting involves using powerful lasers located on Earth's surface. They would direct beams towards special solar elements installed on the cabin, converting light back into electricity. Essentially, the elevator would receive energy without wires. Another concept involves using next-generation batteries that would gradually recharge at intermediate stations. None of these solutions has been implemented yet, but research in this field continues. It is also fascinating to imagine what the construction of the elevator itself could look like. Many people imagine a giant construction crane slowly building the structure upward. In reality, the process would have to work completely differently. Most modern concepts suggest first placing a special space platform into geostationary orbit. This platform would become the starting point of the future project. After that, a very thin initial cable would gradually be lowered downward. At the same time, its extension would be pulled upward toward a massive counterweight. Only after the first version of the cable is secured would special automated climbers begin repeatedly strengthening the structure, gradually adding new layers of material. In a sense, the elevator would build itself. If such a system ever becomes operational, the changes would affect not only space exploration. Some economists believe that an entirely new sector of the global economy could emerge. Imagine large industrial facilities located directly in orbit. Today, many types of manufacturing cannot be moved into space simply because the cost of delivering equipment is too high. But if the cost of transporting cargo into orbit decreases by dozens of times, the situation would change dramatically. In orbit, humanity could produce ultra-pure crystals, unique pharmaceuticals, advanced optical systems, new materials for microelectronics, and even components for enormous space-based power stations. The prospects for building gigantic orbital stations look even more impressive. The International Space Station was assembled literally in small modules, each of which was launched by a separate rocket. A space elevator would make it possible to lift structures of a completely different scale into space. Some futurists suggest that stations the size of a small city could appear. They could permanently host thousands of people, with research laboratories, industrial facilities, and tourist complexes operating on board. Such projects today look extremely bold, but most of the limitations are directly related to the extremely high cost of transporting cargo. Another important issue is safety. If humanity ever builds a space elevator, it will become one of the most important objects of global infrastructure. In terms of significance, it could even surpass the largest seaports, oil pipelines, and international airports. That is why questions of international control arise in advance. Should such an object belong to a single country? Or should it be placed under the management of an international organization? Some experts draw an analogy with the International Space Station, where multiple countries participate. Others believe that such a structure would need to be protected with a level of security comparable to strategic nuclear facilities. It is also interesting how the profession of astronaut would change. Today, a spaceflight requires long preparation, complex medical examinations, and months of training. But if a space elevator becomes a standard way of reaching orbit, the journey could turn into a much calmer process. The cabin would rise gradually, without overloads, allowing passengers to move freely inside. This means that the number of people capable of traveling to space could increase dozens or even hundreds of times. Perhaps one day, going into orbit will feel more like a long journey on a high-speed train or an ocean liner. But a natural question arises. If the space elevator is so promising, why haven't the largest space companies announced its construction yet? The answer is that current technologies are still far from the required level. Even the most optimistic researchers admit that humanity must first achieve a true breakthrough in material science. Without the emergence of a fundamentally new ultra-strong material, all other engineering challenges simply lose their meaning. That is why the largest investments today are directed not so much toward the space elevator itself, but toward research into new composites, carbon nanostructures, and other advanced materials. Against this backdrop, Elon Musk's strategy looks particularly interesting. Instead of waiting for future technologies, SpaceX is already building a transportation system designed to drastically reduce launch costs. In essence, Musk is trying to solve the same problem as the proponents of the space elevator, but in a completely different way. If Starship truly manages to perform dozens and then hundreds of launches per year with minimal reuse costs, the price of delivering cargo to orbit will also drop significantly. This may be precisely why Musk does not consider the space elevator a near-term priority. First, it is necessary to fully exploit the potential of rocket technology, and only then think about next-generation systems. Still, it cannot be ruled out that in a few decades these two concepts might eventually merge. Imagine a future in which massive Starship vehicles deliver components of a future space elevator into orbit, transporting equipment, counterweights, and construction robots. After completion of the structure, rockets would continue to perform interplanetary missions, while the elevator would take over mass cargo transport between Earth and orbit. In this case, the two technologies would not compete with each other. Instead, they could perfectly complement each other, opening the way for humanity to the large-scale exploration of the solar system. That is why today, the space elevator remains not just a beautiful engineering fantasy, but a symbol of how far humanity is willing to look into its own future. At the moment, no one can name a precise date for its emergence. Some specialists believe it will require several decades. Others point to the end of the 21st century. There are also those who are convinced that a terrestrial space elevator will only become possible in the next century. However, almost all researchers agree on one thing. If a material capable of withstanding such loads is ever created, the further development of this technology could happen much faster than it currently seems. And then, the moment that today looks like science fiction could well turn into one of the most monumental engineering achievements in human history.